what was the question on minimums and maximums? I mean,
Can we review them a little bit?
yeah, okay. So all quadratic equations are parabolas. So any equation where the highest power of x is squared is going to be a parabola, always and forever. So if it's in standard form, ax squared plus bx plus c, my highest power of x is 2. That's in standard form. It's going to be a parabola. And in fact, even if it's like c plus bx plus ax squared, it doesn't matter where in the equation or in the expression it is, it's going to be a parabola. Standard form dictates that the highest power of x goes to the left and the lowest power of x goes to the right. So it's going to be a parabola. And it's the same thing if I write it in vertex form. So a times x minus h squared plus k. The highest power of x, when I FOIL out this x minus h, my highest power of x is going to be x squared. So it's going to be a parabola. And the same thing in intercept form. If I have a times x minus p, x minus q, when I FOIL out this expression, my highest power of x is going to be x squared. So they're going to be a parabola. And a parabola can only look one of two ways. It can either look like that, or it can look like that. And in every instance, it's going to have, if it opens up, so if it's up, that's what we call it, technical term, up, right? It's going to have a minimum. And if it's down, it's going to have a maximum. And that minimum or maximum is going to happen at the vertex. It's kind of like by definition. The vertex is going to be either the minimum or the maximum of the parabola.
So it's just the vertex. It's not any different. Finding the minimum or the maximum is not any different than finding the vertex.
That is correct. If you find the vertex, then you know the minimum or the maximum.
But that's just the y-coordinate, right? The minimum or maximum.
That's right. And so the way you have to write it, though, is a little bit different. So like my vertex, if I say, what's my vertex? You might say, okay, your vertex is 5, negative 2. But when you're writing it out and somebody says, what's your minimum? Or your maximum, I don't know whether this one opens up or down, right? If I say, what's my maximum? I would say, my maximum is, so I might write max is negative 2 at x equals 5. So I'm defining my maximum value as a y value. Or if that was a minimum value, then I would say my minimum is negative 2 at x equals 5, depending upon how that parabola opened up or down. And we can find the vertex in any number of ways. So if I have, if it's written in, if I have my quadratic expression is written in standard form, ax squared plus bx plus c, I can go find my vertex by going negative b over 2a. That's going to give me my vertex. If I have it written in vertex form, a times x minus h squared plus k, my vertex is hk. No computation necessary. And once I found my vertex, well, if I found my vertex in vertex form here, then I know my minimum or maximum, because I know it's the y value at the vertex. Everybody okay with that? So if I have my equation or my expression in vertex form, I don't have to do any calculations to find the minimum or maximum. It's the y value of my vertex. If I don't have it in vertex form, and I have it up here in standard form, and I have to do negative b over 2a, once I calculate that value, I have to take that value and plug it in for x in my original equation. Because if I know that's the x value of my vertex, so my vertex in standard form is actually negative b over 2a, is the x value, and the y value is f of negative b over 2a. That is, taking negative b over 2a and plugging it into the function. And then I get what the y value is, and then I have both points of my vertex. And once I know both points of my vertex, I know the minimum or the maximum.
Thank you.
Yes, Julie.
You would have to know also like two other points to figure out if it goes up or down.
Well, if it was written like this, there's something in the standard form, in all the forms. There's something in standard form, there's something in vertex form, there's the same thing in intercept form that's going to tell me whether it opens up or down. And what is the A? What tells me whether it's up or down?
The negative.
That's right. If my A is positive, opens up. My A is negative, opens down. And the way that I remember that, the easiest, is I just go back to my parent function. The parent function, the granddaddy of all quadratic equations.
X squared.
X squared, right? And everybody knows what x squared looks like. Like if I make a parabola, x squared looks like that. So x squared opens up. Is there a negative sign in front of x squared? Nope. So if there's a negative sign in front of x squared, it opens down. And sometimes if I'm really struggling with like a more complex polynomial, which we're going to get into later this week, I'll just go right back to this, and I'll plug in some numbers, and I'll say, well, okay, if x squared, I know I have 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and negative x squared, I know I just go, I can do some points, and I can see, oh yeah, that's right, the negative means it opens down. Is that okay? Yes.
How would you find the axis of symmetry for intercept form?
Intercept form. Good question. So I have intercept form A x minus p x minus q on the board. Third one down. Okay. So y equals that. So whatever my parabola looks like, here's P and here is Q. Those are my two intercepts. My axis of symmetry, by definition, it's a parabola, it's symmetrical. So my axis of symmetry goes right up the middle here. So the way I find the axis of symmetry, if it's in intercept form, is I take P and I add it to Q and I divide it in half. I kind of average them out. I average them out. And that gives me my axis of symmetry. My axis of symmetry also gives me the x value of my vertex. And once I know the x value of my vertex, I can find the minimum or maximum just by taking the x value of my vertex and plugging it back into my original equation. That gives me then the y value of my vertex. Yes?
So then could the vertex ever be the same as the maximum or minimum?
The vertex is always the same as the maximum minimum. The y value of the vertex is always the same as the maximum or minimum because it's a parabola. Just by definition, that's either going to be the lowest point on your parabola or your highest point on your parabola. Yes?
But like how do you, what is the actual maximum minimum, like out of the equation? Like, do you think it's A or is it?
Okay, so let's just do it. Is there a problem that we can do?
Well, I guess on the quiz that we took, 4-1 to 4-4.
Okay.
The question was what is maximum, and it was 7 or 8.
Okay, so what was the problem?
Y equals 3 over 4.
3/4.
Times the quantity of x minus 5 squared plus 7.
Plus 7/8, right? Okay. So vertex form. Great problem, no work. This problem, what was the very first question that it asked me on this one?
What is the axis?
Axis of symmetry. First of all, so this is A times x minus h squared plus k. My axis, my vertex is going to be h k. The x value of my vertex is my axis of symmetry. Everybody good with that? Everybody okay with that? Okay. I can look right up here. Looks very similar. My axis of symmetry is 5. That's my h value. Everybody okay with that? Okay. What's the next question?
Does the function have a minimum or a maximum value?
Okay. Is my a positive or negative? Does it open up or down? If it opens up, it means I have to have a minimum, right? Okay, so I have to have a minimum because it opens up. Opens up. A is greater than 0. Okay, what was the next question?
What is the maximum and minimum?
Okay. HK is my vertex, right? Here's K. So my maximum is 7/8.
The y, okay.
Right? It's the y value of my vertex. No work on that problem.
So you have to write, well, it's the minimum, not the maximum, right?
Yes, that would be the minimum. Yes, correct.
Oh.
Sorry. Yeah.
Okay, so you'd write minimum equals 7/8 with x equals 5. So
Yep. Yes.
If we didn't write it like that and we wrote 7/8, 5, would we get that one?
Yes. Well, I mean, you get some points off. But yeah, it has to be written. Write it the right way. Yes.
If you just put the x the y value, is that okay? Do you want us to add 5?
You really should put at x equals 5. So don't make me mess around with these quarter point irritating things.
Oh, so I was wondering if it was like
No, you should definitely identify the x value where it's at the minimum. Yeah, absolutely do that. Yes.
the minimum or maximum is always going to be like the x value, while the axis is going to be the y value.
No.
Other way around.
Other way around. Axis of symmetry. So let's take a look at a picture here. Here's my xy axis. Now, in order for it to be a function, the parabola has to kind of look like that. I mean, I can't have that's not a parabola sideways, right? I mean, it is a parabola, but it's a sideways parabola, but it's not a function. Because it's not, everybody clear on that, right? It's not a function because it doesn't pass the vertical line test. So all my parabolas are going to either open up or down. If I'm going to draw my axis of symmetry, the axis of symmetry is just what it sounds like. It's the line through the parabola that defines where the two sides are symmetrical. So if I'm drawing a line that can make the two sides symmetrical, that line right here has an x value. It does not have a y value. It has an infinite number of y values. So my axis of symmetry is always going to be my x value, and then the minimum or maximum is always going to be the y value. Okay with that? Everybody okay with that?